Hey students, we're going to be taking the nomenclature we've been working with and start bringing it to the next step. And that is looking at using the nomenclature to turn reactions we do in lab into chemical equations. And equations are what we write on paper to show what we do in lab. So in lab, I'm holding stuff and I'm talking about, hey, here's some silver nitrate. And I say it with words, but on paper, we don't want to take the space to write that all out in words. So we're going to be turning the words into symbols, and that's going to be using our nomenclature. So follow along with me. At the top is some very important information to introduce to you. And I'll be coming back to these lists every so often. What we're going to do is these 5 examples, and I hope you have something erasable because that would be super helpful as we go through these examples together. All right, so we're going to use nomenclature. Before I begin, I just want to lay down 2 ground rules. We have both ionic and covalent nomenclature, and they're separate systems. So if it starts with a metal, it's ionic nomenclature. You're going to find charges, crisscross, and reduce. If it starts with a nonmetal, you're going to be using covalent nomenclature. It's all about the prefixes. Notice I did not say crisscross and reduce. There is no crisscross and reduce. It's just prefixes, okay? So as I go, that's the rules for it that I'm going to be looking at. So let me get something to write here. I'll write with this. Okay, so we're going to get started here, I think. Okay, can I annotate now? Okay. All right, so solid tin liquid bromine yields solid tin for bromide. So we're going to start with this tin here, and I'm going to have tin as SN. Okay, and this is a plain element, so go up to that list at the top, and you will notice with that list at the top that there is no tin in the list, so it just stays this way. Now, it does tell me it's solid, so something I want you to start getting used to, we're going to put a little S there for solid. That's just going to communicate the phase of matter. Liquid bromine, so I have bromine, Br, and again, go up to that list at the top, and you will see, yes, bromine is in that list, so it gets the little 2 when it's by itself, and right now, it's by itself. It's not in a compound. And we were told it's liquid, so there we go. Okay, yield is an arrow, and now I have solid tin for bromide, okay? Well, tin is SN. Now, what's that for? Tell us. Not the amount of tins, it tells us the charge of the tin. So the tin's +4, okay? Bromide is still Br, still a -1. And so, oh, it started with a metal, so it's ionic. I'm going to crisscross and reduce. Okay, I'm not going to write the 1. And now I need my eraser because I'm going to erase those charges. There we go. And I was told it is a, no, yes, I want that. Thank you. No, come on. How do I oh my goodness, of course. Why will you not behave? Okay, what if I pick a different color? Still on eraser. Okay, well, this is fun. Why can't I get off my eraser here? I don't want to erase anything more. Can we stop it, please? No, apparently we can't. Do why? Okay, I'm going to clear that and we'll just try this all over again. That worked. Okay. Yeah, silly technology. Okay, and we were told this is a solid, so there we go. Now, as we turn our word equations, the words we would talk with in lab, into formulas that we'd rather write on paper instead of all these words. As you can see, it would take a lot of space to write all these words. We also need to show what was going to happen in nature and in lab, and that is the law of conservation of mass needs to be used. So in other words, what I start with, I have to end with. So follow along with me. I have 1 tin on this side, 1 tin on this side. So far, so good. But I have 2 bromines on this side, the left side, and 4 on the right side. So to make it balanced, to make it the same, literally, I'm going to now add a coefficient of 2. Now I want to make this point. It's not that that's the only coefficient I have. When we don't write a coefficient, just like in math class, there is a 1 there, there is a 1 there, okay? So it's 1, 2, 1 as the coefficients. But I needed to show a 2 there to prove on paper that the mass will be conserved like it really will be in lab. Lab, it'll happen automatically. Paper doesn't happen automatically, so you need to do that. Okay, let's go to the next one. Dihydrogen. Okay, notice it starts with a starts with a nonmetal. It's covalent. It's going to use a prefix. All I do is use the prefix H2. Monoxide is O. Tells me it's a liquid. Oh yeah, that's water. And by the way, that was supposed to be an L. Okay. And, okay, and is plus sign. Solid dinitrogen trioxide again. Okay, so covalent. I'm going to use the prefixes. No crisscrossing, no reducing. Don't do it. It tells me it's solid. That's an S. And then I'm going to make aqueous hydrogen nitrite. Okay, now that is nitrite is a polyatomic ion. It's going to bond ionically. So I need to look up charges, crisscross, reduce, stuff like that. So here's my hydrogen. It's going to be +1 because it's group 1A. And nitrite, go to the list of polyatomic ions, and you're going to see it's NO2, nitrite. Be careful what you look up. And it's also -1. Well, that's kind of handy because what do I get when it's a 1 and 1? Okay. So I'm not going to write the ones that I would crisscross there. And I think it's just going to pop back in this way. Hey, I think that worked. And it tells me it's aqueous. So AQ, that's an AQ there. Okay, and now let me balance. So 2 hydrogens on the left, only 1 on the right, put the 2 there. Now watch this, by putting the coefficient of 2 there, it makes 2 hydrogens, but it also is going to make 2 nitrogens. Oh, but that's actually okay, because I already have 2 on this side. That works out well. But it also is going to make 2 times 2 or 4 oxygens on the right here. Oh, but okay, look, I have 3 plus 1 is 4 oxygens there. So it's balanced. So there we go. Okay. Now, I'm not saying it has a balance with like a 1 or 2 or something. Okay. Like they could get big. Now, I think one of them on this worksheet, there's like some 21s and 16s and such roaming around, and that's okay. But you want to just go through and keep guessing and checking until it works. Okay. Now, by the way, as I move on here, I want to point out that I just said very much so it's true. It's guess and check, but we don't call it that, okay? We call it balancing by inspection. That makes us sound smart. So we are balancing equations. We're going to be balancing by inspection, which means we're guessing and we're checking, but we don't call it that. So just letting you know, we're balancing by inspection. Okay. Anyone asks? That's what we're doing. Balancing by inspection. All right. Barium carbonate starts with a metal. So there's my barium. I'm going to need a charge. It's in group 2A. There we go. Carbonate. Find it on the list. CO3. It's a -2. Ooh, that's pretty handy. It's a 2 and 2. And it's solid. And so I'm going to erase the charges because they reduce to 1s, and when I crisscross 1s, it's not going to like matter. Okay, I'm not going to write 1s. That's a me thing. You can write 1s. I don't really care. All right, yield solid barium oxide. Okay, now in case I need to say this, if you haven't caught on already, barium was a +2 on the left. It's still going to be a +2 on the right. Okay, the charge stays the same. Shocking, I know, right? Okay, oxide, oxygen is a 2. So again, when I crisscross that, I see that that is actually going to reduce to 1s, and I'm not going to write 1s. So there we go. Okay. And carbon dioxide. Ooh, non-metal, covalent, use the prefixes. Now we don't write monocarbon, but that's what is intended. It's a monocarbon dioxide and it's gas. Okay. And now that I've written it all, I'm going to go through and balance. So let's see, 1 Ba on the left, 1 Ba on the right, 1 C on the left, 1 C on the right, 3 O's on the left, 1 plus 2 is 3 O's. I really didn't mean to make that little line there. Okay. So there we go. That is that one. It's done. That's all there is to it. Okay, so we're using our nomenclature in a new way today to move us forward in terms of, well, I already used brown, in terms of, I used red earlier. I haven't used brown yet. Okay, in terms of we're using the nomenclature to get us into the idea of writing and balancing chemical equations. This is the logical next step, and what we will continue to do in the future, very near future, is these balanced chemical equations. Okay. Aluminum sulfate, aluminum is Al. It's a +3 because it's in group 3A. Sulfate, you look it up, it's an SO4 with a -2. So I'm going to crisscross 2 there, 3 there. How did I know to crisscross? Because it started with a metal. And when it starts with a metal, you always crisscross. Like I can promise that. That's the way that's going to work out. It is, oh, it doesn't tell me what it is. It doesn't tell me solid, liquid, or gas. So what are we going to do in this case when it doesn't tell me? We're not going to worry about it because I just want you to see sometimes you just aren't told. Now, I know from personal experience, because I actually could like grab the jar of aluminum sulfate out of the stockroom. I know it's a solid, but I wouldn't expect you to know. Okay. So if it doesn't tell you the phase of matter, don't worry about it. Just don't write anything. Okay. So I got my aluminum sulfate, and here's my iron 3. Oh, what's the 3 say? The amount or the charge? Well, it's a metal, so that's the charge because I've got to crisscross and reduce. Phosphate's a PO3 with a -3. Okay, those are both 3s. I know my handwriting's awesome, isn't it? Yeah, okay. So those are both 3s. They're going to reduce to 1s. So I could write 1s like that if I wanted to, but you know what? I don't do that. And I don't know the phase of matter. So there we go. Iron 3 phosphide is that, and it's all good. Okay. So now I have yields. So it's time for an arrow. And I have aluminum, still a 3. And phosphite, PO3, still a 3. Ooh, that was handy. So that's going to reduce is the word I'm looking for. No, I want eraser. That's going to reduce. And then I'm going to have iron 3. And again, since it's a metal, it's going to use charges. We're going to crisscross. So if I'm going to crisscross, I need a charge. And then sulfate. So the 2 goes there, 3 goes there. There's a crisscross. Okay, and I'm going to erase the charges. I'm done with them. Okay, now let's finish this up. Okay, I need to balance. So let's see what we got. I have 2 aluminums on the left, 1 on the right. So I'm going to put that there. Now I'm going to give you a little hint on balancing. Does the grouping of phosphide change? It starts as phosphide, it ends as phosphide, it stays the same. Same with sulfate. Do you see how it's sulfate both times? That means we can balance it by the group and not just by the element. So yes, I have 2 aluminums here, but now I also have 2 phosphite groups. Over here, I only have 1 phosphite group. So I'm going to put a 2 there. So now I have 2 phosphite groups, but I also just made 2 irons. Oh, but over here, 2 irons is actually really good for us. So, okay, cool. And over here, I have 3 groups of sulfate. And over here on the left, I have 3 groups of sulfate. So actually, it's all balanced now. But you'll notice I like to bounce back and forth like that. So one of the things I do when I think I'm done is I just go through linearly. So 2 aluminums, 2 aluminums, 3 groups of sulfate, 3 groups of sulfate, 2 irons, 2 irons, 2 phosphite groups, 2 phosphite groups, balanced. Great. Okay. I wish I had a darker purple, but we're going to try this lighter purple. One last one that we're going to do as an example, and then you're just going to, finish my examples, keep going with it. Okay. You've got 20 of these for practice. And again, most of this is nomenclature. That's why we're doing this now, because it's nomenclature review. We're just adding the next logical step to it, balancing them after you write them. Okay, potassium is K, and it's a plain element. So go up to that list and look through the list, and none of those, the potassium's not on the list. So it just stays as it is. And my tendency is to just write water. And I'm okay if you do too, but I hope you know that water's H2O. So look, if you don't know that water's H2O, like memorize it now, okay? Okay. We got yields. Potassium hydroxide starts with a metal, so I'm going to need a charge. Hydroxide's in our list. It also has a charge. Well, it's really handy they're both ones, because when I crisscross ones, I don't need to write anything. And this is the way to get it to work again. Okay. And yes, thank you. Hydrogen gas. Okay, so that's hydrogen. Go up to your list. Yes, hydrogen is in the list. So it's an H2, and I couldn't not put gas there. It was, I just felt I had to. Okay, so I'm going to put a little G for gas. Okay, now I need to balance this. Well, I do see like I've got two H's here, two H's there. So far, so good. Okay, let's check the potassiums. 2 K's here, 2 K's here. So far, so good. 1 O here, 1 O here. So far, so good. But here's what I want to point out. Okay, did you notice what I messed up? I saw these 2 H's and I saw these 2 H's, and I did not count that H. And I did that to like show you that you want to be very careful to be sure you count it all. I actually have 3 hydrogens on the right and only 2 on the left. Well, when I see 3 and 2, I kind of think like 6. Now, again, this is guess and check. So I'm going to guess 6. So to make 6, I'm going to put a 3 there, and I'm going to put a 2 there and a 2 there. So I have 4 H's plus 2 H's. Okay. And now I've made 2 potassium. So let me fix up potassium. And now I have 2 oxygens here, and I have 3. Okay, well, I fixed up my hydrogen, but I broke my oxygen. Okay, now I told you it was guess and check. What's this tell us? This tells us we need to guess something else. So I'm going to just erase the coefficients I already had. And I want to point out when you're guessing and checking, it'd be best if you do so logically. I had guessed a 3 in this position. It didn't work. I'm going to go back and guess a 2. I literally had a student come to me saying, Mr. Billen, I can't get this to balance. And I'm like, okay, what have you tried? Well, I tried a 2 and I tried a 3. So then I tried a 7. And I'm like, why did you skip 4, 5, 6? Okay. Be logical with your guesses. Try 2. If 2 doesn't work, try 3. If 3 doesn't work, try 4, and so on. I'm not saying you can't use a 7. I'm just saying what happened to the rest. And by the way, on that one, it was a 4 that would have balanced his equation. But anyway, okay, so I tried a 3. 3 didn't work. I'm going to be logical. I'm going to guess 2. Now I have 4 H's here, so I'm going to put a 2 here. So I get 2 H's plus another 2 H's is 4 H's. That's so far so good. And I have 2 oxygens here, and I have 2 oxygens here. So far so good. And I have 2 potassiums here, and ooh, I don't have 2 potassiums there, but good news, I can fix that pretty easily. Boom, there we go. Okay, all fixed. There we go. That one's bounced. Oh, but check this out. I have a 2, 2, and 2. Can't I reduce those coefficients? Well, I just lied to you, didn't I? We don't just have 2, 2, and 2. We have 2, 2, 2, 1. Right? I don't write ones, but there's a 1 there. Can I reduce it with that 1 there? No. What if all 4 were 2s? Yes, you would reduce it. What if you had 2, 4, 4, 2? Yes, reduced to 1, 2, 2, 1. What if you had like 3s and 6s? What if you had like a 4 and an 8 and a 12 and so on, okay? So you might glance at the coefficients at the end and just ask yourself, hey, can I reduce these? Because if you can, you need to. All that means is it would have balanced earlier with a lower number, and you just for some reason missed the lower number. I'm glad you got it to balance, but do check that it is the lowest ratio. Okay, those are the examples I'm doing with you. The rest are on your own. We had class time to work on them. Now it is homework. I wish you luck. And of course, come to tutorials if you'd like assistance, because that's what tutorial time is for.